heuristic example is about a capacitated vehicle routine example. So this problem normally is considered as a very difficult problem. So it's very common to use heuristic algorithms to solve. So first, this problem is from teaching notes from our colleague Jens Lusko. So I can show you. So before you try to attempt this problem, you should read the PDF material, Clark and Wright's savings algorithm. So in this notes, Jens actually described the problem, the algorithms in the very detailed level. So do go through the text and understand the algorithm. Then I will show you how did I actually achieve this result, the solutions based on this algorithm for the numerical example. So in this PDF file, Jens also actually gives the clear description about this problem. So we consider a problem with the 5 customers. So you can see the transportation cost between all pairs of the points are shown in the following table. So 0 represents the depot, so the warehouse or some central place. So the costs are symmetric. So for that reason, only the upper half of the table is filled. So you can see from location 1 to location 2 is 21. From location 2 to location 1 should also be 21. So that's a simplification of the problem. You may argue, so they can be different. You may need to drive it through the different routes, but here we assume that the direct routes is symmetric. And furthermore, we have the customer's demands that must be delivered from the depot are given in the following table. So you have 5 customers located in the 5 cities, and they have the demand at different levels. And now the question is, you have the vehicles to deliver the products to the customers. Then the vehicle routine problem is normally the cars, the trucks, the trucks have the fixed capacity. In this problem, we assume the truck has a capacity of 100 units, and then you can see how many items it can carry each time. So if they carry 1, 2, 3 in the same truck, same vehicle, then you can see they actually already violate the capacity of 100 units. So that's how you understand the demands and the capacity. And also, the idea of this heuristic algorithm, actually I clarify them in our lecture slides. So this is the central idea about the Clark-White saving algorithms. So if the worst solution for this problem is 0 is a depot. So you send a car to deliver the goods to the customer I, and then unload the goods and drive back to the port and carry the new goods and deliver to customer G and go back to the port again. This actually is possible, but if you consider an alternative route, you send the item from, you actually carry the demand for both customer I and customer J in the same vehicle, and this vehicle visit customer I and then continue to visit customer G and then come back to deport. Then we can easily calculate the cost for the two different routes or different alternatives. And then if you take the difference between these two routes, you can see actually there is a clear saving. So if we look back to this two sketch, you can see the route from customer I to the port and the route from customer deport to customer G actually are saved. And then you add one new path from customer I to customer G. So that's why we call it savings, two savings minus one expense. So that's how you calculate the cost savings. And for more details, do check the reading material. Now let's try to see the numerical example and see how can we implement this algorithm in Excel. So again, we do a manual calculation for this problem. So we have this parameter information given. So we said it's a symmetric information. So this data just filled in. You can see they are symmetric. And then in order to implement the Clark-White saving heuristics, first we need to calculate saving matrix. So based on the idea on these little two small figures or graphs, now you can see we can calculate the savings. For example, if we connect two customers, customer 1 and customer 2, and you can see how much you can save. So that's actually how you calculate. You save the route from deport from the customer 1 back to the deport, and from deport to customer 2, of course, you add a cost from customer 1 to customer 2. So that's how you calculate the savings. So if we could save cost by connecting multiple customers in one single trip, then we'll save the cost. So that's also the purpose or the idea of this algorithm, to find the possible routes for each vehicle and decide how many trips you need to design in order to minimize the total cost. So we continue to calculate the savings for each pair of customers. So then you can see I got these different values. This calculation is manually because I remember the cost saving formula, then I know which part is saved, which part is added. So then I can calculate the savings. So the next step, you sort or we rank the savings by the pairs. So here, if we consider from customer to customer, so the savings to connect customer 1 and 5 together give you the highest saving. So in this sense, you can also think about if you need to connect two customers, definitely you put customer 1 and 2 in the same route because it will save the most. And the next pair is 1 to 2, and then you will save 38. So this actually is an exhausted list. You find all the possible savings between each pair of the customers. After you find this saving list, then of course, when you set up the route, you choose the pair with the highest savings. So we start from the vehicle 1, or we say the first trip or first route. So you have the 5 customers here, and then you decide if you are going to deliver the goods to this customer in this trip or not. So here we have a decision variables, 1 or 0. So the idea is I put this part calculation because I would like to calculate if this route or this chain will violate the capacity constraint for each vehicle. We know this vehicle's capacity constraint is 100. So actually put the 100 capacity constraint here, and also I give the demand information or parameter in this table. I know how many units they need. So for example, now what customer 1 and 5 should be connected. So I choose customer 1 and 5 in the first trip, and then I continue to think to try to add other customers into this route. So I check the 1 is already connected, so I check the customer 2 and 4. So I continue to check the saving list. So the second pair to save is 1, connect customer 1 and 2, and then you can see the customer 1 and 5 already. So I take this one off. So initially I put 1 and 5 customer in the trip, and then the customer 2 and 1 connected together will save. So I would like to put customer 2 in this trip as well. So the demand for customer 2 is 35. So let's see if I choose to connect. Why I cannot add a number here? Then you can see I needed to load 104 units into here is no. I needed to add 104 units into my vehicle, which actually violates my capacity constraint. So it's not feasible. So I should not add customer 2 into this trip. So I delete it. And then I continue to check this list. And only if the customer can connect to the current route 1 to 5, otherwise I cannot add. So I continue to check the next pair is customer 1 and 4 pair will save. So I put customer 4 in this list. Then you can see, okay, the total demand actually is lower than the capacity. So that's yes. So I cannot add more because the demand are quite high. So I'm done with this route. So then you can show for the vehicle 1, they drive from depot to customer 1 to customer 5, then to customer 4, then come back to depot. So that's the first route. And we are not done with all the customers yet, so we need to initiate the second trip or second route, or we say you need to send out the second vehicle. So apart from the customer 1, 4, 5, I still have customer 2 and 3 not served. So I just put them together. So we'll save actually 13 anyway. So in the second trip, I make a tour from depot to 2 to 3 back to depot. So that's how I create this trip or this route. And then if you want to use a traditional linear programming idea, then you can easily calculate the total distance you drive. So I put the sequence of the tour into this matrix. So as from node 0, which is depot. So if I name this as depot, then I drive from the depot, drive to customer 1. So I choose this value is 1. And then customer 1, drive to customer 5. So this matrix, this cell should be 1. And customer 5, drive to customer 4. And the customer 4, back to depot. So I put this once in, and then continue with the theorem. So I have the second vehicle start again from depot to customer 2, and customer 2 to customer 3, and customer 3 come back to depot. So that's how I put these values into this matrix. So I can calculate a total distance or total cost based on the cost parameter and your final decision. So that's how we used this heuristic method to solve the capacitated vehicle routing problem. So after we do these manual calculations, actually make this problem clearer. So in the future, you may think about to use other heuristic method to solve even more complicated vehicle routing problem. But this type of problem is very popular in the logistics companies or shipping companies. So this actually is the first implementation of this heuristic method. Is actually called a sequential method. I named this worksheet as a sequential. So that means I actually each time only generate one route. So if we could generate multiple routes at the same time, so actually this is called a parallel scheme. So it's actually another option to implement the same saving heuristics method. So here I just show the difference between the parallel and the sequential method. So the major difference is when how you actually generate the routes. So as we said, all the other informations are actually same. So when you generate routes, so this time you can actually initiate two vehicles or two trips at the same time. So in order to save the cost, so the first pair is 1 to 5. So you connect the customer 1 and 5 in the route 1. So I take this 3 out. And then next step, you check on your list. You can see 1 and 2 can be connected, but if I add 2 into this trip 1, then actually they violate the capacity constraint, so which I cannot do. So I delete this. So next step, I check the list. So in the cost saving list, I found if I connect the customer 2 and 4 together, they give me higher saving 36. So I initiate a second route, put the customer 2 and 4 in the same trip. And then that's called a parallel generation. So I generate actually 2 parallel routes at the same time. So now I have the customer 3 left. You can see I cannot actually connect customer 3 into. So I continue to see the cost savings that I found in the row 28. You can see I connect customer 1 and 3 together, then we'll save 19 units costs. So I put actually customer 3 in the first route. And then I still satisfy the capacity constraints. You would ask if I put customer 3 in the second route. So actually 2, let me try. As capacity wise is okay. Yeah, but here you can see connect the customer 2 and customer 3 together will give you lower cost saving. So that's why I connect the customer 3 in the first route. So in these things, you can see actually they create you a cost actually lower is 171. So that means the parallel algorithm actually gives the better result. So that's the manual implementation of the Clark-White saving heuristics. Here I have the third worksheet. If you noticed, actually this is exactly same implementation for the same algorithm for the same example. So the only difference is here we put the method to calculate cost savings. If you still remember, I explained we actually needed to calculate saving matrix based on this relationships introduced in the algorithm. And then now in this third worksheet, I actually put these calculations for cost saving into a macro. We write a short VBA code to calculate the savings. So here, let's see how it's working. I delete this two cells. So this information basically is the cost saving information is obtained by run the macro under the button. So actually, I delete this information. This cost saving actually is the most critical part or information for the algorithm. So now, if I click this button, so you can try on your Excel workbook. So I click this button. Now you can see I generate the cost savings on these columns. Then the following calculations are all based on these savings. So first I rank the savings, and then I select the routes. So you can try the parallel algorithm and the sequential algorithm. So these are also same as the previous manual steps. Here again, the macro is not required in the exam, but it would be nice you can check the macro actually will help you to simplify some trivial work. So here I can show you the code in this macro. So you can see if you click the developer tab in the menu, Excel menu bar, and then click the VBA. Now you can see the VBA applications open, and then under the modules menu, and then you find the module 1. So all the codes running in this Excel workbook actually is written here. If you go through this commands or these codes, you can see that just shows some repetition work by the code. So you first define the variables you need, and then you choose and you read the parameters into your code, and then you choose where to write the output. So the output actually here, these two cells basically calculates the cost savings. And if you see how this actually calculated, so this cost savings, so we already said, is based on the save 2 routes and add 1 more routes. So this is just simplify the work. So now if you have different type of problems, you can actually change this code to calculate savings quickly. So if you're interested, you can check this macro-based solutions. So just for your reference or your interest, it's not required in the exam. So that's about the last example. Contact me if you have any question about that.